Um, Greetings. I've got the question paper with me. I'm not sure uh, as to when it was written, and I'm not really sure about the grade. But 60% of grade 12's work is grade 11's work. So grade 11, grade 12, and I think grade 10 as well, eh? So without any further ado, let's dial. So for X, it was 28 marks. First question: 3x into 2x minus 1 is equals to 0. So now we have two factors. And the factors are equal to 0. We can apply the 0 principle. 3x is equals to 0, or 2x minus 1 is equals to 0. We divide both sides by the coefficient of x. Therefore, x is equals to 0. Or this side, we transpose the 1, it changes sign. Divide both sides by 2, and therefore x is equals to a half. We take 0, we plug it here. If this is 0, 3 times 0 is 0. Any number multiplied by 0 is 0. We take a half, 3 by half, it will be 3 over 2. And then here, 2 by half is 1. 1 minus 1 is 0. 0 by this is 0. So both the values are correct. Moving on to the next question. 2x plus x is equals to 4, and then in brackets they're saying leave your answer correct to two decimal places, telling us that we have to use the formula method, right? So a standard formula, we put it in standard formula. It's like this, right? In this case, our a is 2, our b is 1, our c is negative 4. The equation x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a, right? Okay, b minus 1 plus or minus the square root of b is 1 squared minus 4, a is 2, c is minus 4, all divided by 2 into a is 2. Therefore, we have minus 1 plus or minus the square root of 1 squared is 1, negative by positive, negative, negative by negative, positive. 4 by 4 is 16. 16 by 2 is 32. So we have 32 all over 4. Therefore, the answers are x is equals to minus 1 plus the square root of 33 all over 4, or x is equals to minus 1 minus the square root of 33 all over 4, right? They said leave your answer correct to two decimal places, so you will do that. I do not have a calculator with me. Moving right along. The next question. Inequalities. So for x, if x squared is greater or equals to minus 2x, right? Okay, we want the one side of the inequality sign to be 0, so we will transpose the 2x. So x squared, the 2x, it will change sign, plus 2x is greater or equals to 0, right? We're good. We can search for our critical values. We change the inequality into an equation. Right now we can solve common factor x, and then here we'll be left with 2 is equals to 0. 0 principle, x is equals to 0, or x plus 2 is equals to 0. This side, x is equals to minus 2, right? But if you remember, this is not the solution. These are just our critical values. We draw our young graph. The first value is negative 2, and then we have a 0. So you choose a value that is less than negative 2, a value that is between negative 2 and 0, that will be negative 1, or any number that is greater than 0, right? For simplicity, let's choose a number that is greater than 0. Let's choose 10. So if this is 10 here, or let's choose 5. If this is 5, this is 5. And we are only interested in the sign, not the value. So 5 plus 2 will be 7. 7 by 5 is positive by positive. It will be positive. We said the signs alternate. If this is positive, this will be negative. This will also be positive, right? We are looking for values that will make this thing greater or equal to 0. Numbers that are greater than 0 are positive. So our solutions goes there. and it also goes here, but these values are included because these values will make this thing to be equal to 0, right? They said greater or equals to. So our solution is x must be less or equals to -2, or x must be greater or equals to 0, right? Those are our solutions. Moving right along. Moving right along, the next question. Given k plus 5 is equals to 14 over k, right? The first question, solve for k. Solve for k. So if we were to solve for k, we wanna eliminate this denominator. So how best do we eliminate it? We multiply each and every term by the denominator, right? The denominator is k. So if we multiply each and every term, we have this k. We will multiply by this k. We multiply each and every term by k, right? Is equals to 14 over k. This also is multiplied by k. So we multiply each and every term by k. K by k will be k squared. This side 5 by k will be 5k is equals to, this one will go with this one. We have 14, right? Therefore, we have k squared plus 5k minus 14 is equals to 0, right? Okay. A is 1. Then our factors for the first term will be k and k. The last term is negative. Our signs will be different, right? The factors of 14, it's 1 and 14, is 2 and 7. We want those with a difference of 5, is this combination. We said the bigger term takes the sign of the middle term, right? The bigger factor is 7. It will take the sign of the middle term. Therefore, the zero principle, k plus 7 is equals to 0, or k minus 2 is equals to 0. Therefore, k is equals to -7, or k is equals to 2, right? K is equals to -7, or k is equals to 2. We're good. Moving right along. K is -7. If you remember, k is equals to -7, or k is equals to 2, right? Because the next question they're saying, hence or otherwise solve for x if x is x plus 5, hence or otherwise x plus 5 plus 5 is equals to 14 over x plus 5. So when they are saying hence or otherwise, they are saying basically they mean the information that you just got more answering on the question above. Use it to get the answer for this one. If you remember the equation that the equation LIK was k plus 5 is equals to 14 over k. If you compare these two equations, you can see that basically where there was k, they replaced with the square root of x plus 5, right? That's what they did. That's why we hence or otherwise. So if we solve for this equation, we will get that x, the square root of x plus 5 is equals to -7, or the square root of x plus 5 is equals to 2. If we solve, because basically these two equations are the same. It's like from this equation to this equation, we simplified and said let x plus 5, let the square root of x plus 5 equals to k, right? And then we solve. But then eventually we remembered, or no, we are not solving for k, we are solving for x. Then we go back. Wherever we see k, we substitute with the square root of x plus 5. So basically that's why they said hence or otherwise. We don't really need to solve this one because the result will go dim, right? So we will just take it from here. From here, we want to eliminate the root sign. We know that if we want to eliminate the root sign, we square. Whatever we do on the left hand side, we also do on the right hand side. This one will go with this one. Therefore, x plus 5 is equals to 7 squared is 49. X is equals to 49 minus 5. X is equals to 44, right? The same will happen this side. We want to eliminate the root sign. So what do? We square both sides. All right. The square will go with the root sign. X plus 5 is equals to 4, x is equals to 4 minus 5, x is equals to minus 1, right? So then with these ones, the value, the square root, it's always advisable to go back, substitute, right, to check if the values are both applicable. They are both correct, but are they both applicable in this sense? So if we substitute here the square root of 44, you can see that 44, we will get 49. The square root of 49 is 7, not minus 7. So we can say this one is not applicable, right? But then here, if we substitute minus 1, if we substitute minus 1 here, minus 1, we will get 4. The square root of 4 is 2. Therefore, this one is correct. Is the only applicable value. Moving right along. Moving right along. I guess it's a simultaneous equation. Okay, simultaneous equation minus 3y plus x is equals to 1 minus 2xy plus 9y squared is equals to 17 minus x squared, right? So we have two equations. This is equation 1, this is equation 2. Okay, we can say x is equals to 1 plus 3y. This will be equation 3. So from equation 1, we made x the subject of the formula to get equation 3. So now we substitute equation 3 into equation 2, right? So wherever we see x more equation 2, we put this. So we have minus 2y into what is x? Plus 3, 1 plus 3y plus 9y squared is equals to 17 minus x is 1 plus 3y all squared, right? Okay. So from here, let's multiply out this by this. It's minus 2y. Minus 2y by 3y. It's minus 6y squared plus 9y squared is equals to 17 negative minus inspection square the first. 1 squared is 1. Multiply together. 1 by 3y is 3y and double. That will be 6y squared the last. That will be 9y squared, right? Okay, we have minus 2y minus 6y squared plus 9y squared is equals to 17. We want to multiply out by the negative. So we have negative 1, negative 6y, negative 9y squared, right? We want to take everything to one side. So in this case, minus 2y. And then if, okay, let's group. Same time, let's group the like terms. We take this one, it will change sign. So it will be plus 6y, right? Okay, and then we had minus 6y squared plus 9y squared. If we transpose this one, it will also change sign, plus 9y squared, right? Okay, we are left with 17 minus 1, it's 16, and then we transpose it, it will be minus 16 is equals to 0. I hope we're good. I hope we're following. So we group in the like terms. We group in the like terms. This one's negative 2y plus 6y. It's 4y. And then this plus this, 9 plus 9, that will be 18y squared. 18y squared minus 6, that will be 12y squared, right? Minus 16 is equals to 0, right? If we put it in standard form, we have 12y squared plus 4y minus 16 is equals to 0, right? In this case, we have a common factor, which is 4. If we take out 4, we'll be left with 3y squared plus y minus 4 is equals to 0. We can divide both sides by 4. We are solving, no problem. This one goes with this one. Therefore, 3y squared plus y minus 4 is equals to 0, right? I know we can take it from here. we can take it from here. We know now it's easier to factorize when a is 1. That by that will be left with y squared. But remember, this is the part we do go by rough work. They do not want to see this part. So in this case, we'll have y squared plus y minus 12 is equals to 0, right? Okay. The first a is 1. Therefore, the factors for the first term will be y and y. The last term is negative. The sense will be different. The factors start off with a difference of 1. We have 1 and 12. We have 2 and 6. We have 3 and 4. Here is our combination. The bigger factor, which is 4, will take the sign of the middle term. Therefore, 4 will be positive, right? 4 will be positive, and then this one will be negative. But then we remember that, hey, comma tomon, we multiply the last term by 3. So we divide both the terms by 3, right? Therefore, we have okay, this is the part we can write. This is the part we can then show them. We have y minus 1, and then this one will come here. We have 3y plus 4 as our factors is equals to 0. 0 principle. Right? Y is equals to 1. Transpose the 4. It will change sign. And then divide by the coefficient of y. Right? So those are our two values. Those are our two values. Y is equals to 1, or y is equals to minus 4 over 3. So we can come here to get the corresponding x values. So x is equals to 1 plus 3 into y. Y is 1. Therefore, this will be 4. So the pair of coordinates is 4 and 1. Remember, coordinates are x and y. So x is equals to 1 plus 3 into minus 4 over 3. This one will go with this one. Therefore, we have 1. Positive by negative is negative, minus 4. This one will be negative 3, right? So the pair of coordinates, negative 3, negative 4 over 3, right? Ow. Oh, we had to work. Moving right along. Moving right along. Yeah, we had to work for that one. It was 6 months. We had to work for it. Moving right along. Second last question. Nature of roots. I've been promising on making a video on nature of roots. I will. Determine the values of p for which x squared plus 4x plus 2p is equals to 0. Determine the values of p for which x squared plus 4x plus 2p is equals to 0 will have real roots. So for real roots, the discriminant must be greater than 0. For real roots, the discriminant must be greater or equal to 0. Because, okay, if the discriminant is equal to 0, the discriminant are equal, but they are also real. So now they didn't specify, they just said real. So for real, the discriminant must be greater or equal to 0, right? Okay, if they specified which form of a real and equal, the discriminant equal to 0. I'll make a video on nature of roots. Okay, the discriminant, we know that it's b squared minus 4ac has to be greater or equal to 0, right? B yarena 4, so 4 squared minus 4a yarena is 1, c yarena is 2p. The constant, whatever is the last term, kiona c yarena must be greater or equals to 0, right? So 4 squared is 16. Negative by positive, negative, negative by positive, negative. 4 by 1, 4 by 1 is 1. 4 and 4 by 1 is 4. 4 by negative 4 by 1 is negative 4. No, here is the sign already. 4 by 1 is 4. 4 by 2p is 8p must be greater or equals to 0, right? So here we can see negative 8p. We can take it that side, or we can still transpose the 16 must be greater or equals to negative 16. And then we want p, so we divide by the coefficient of p, which is a negative. And you know, if you divide by a negative number, what happens to the inequality sign? It changes, right? It was greater or equals to, now it becomes less or equals to. Negative by negative is positive. 16 divided by 8 is 2. So if p can be less or equals to 2, this thing will have real roots, right? I'll make a separate video on check roots, I promise. The last question. Given f of x, given f as a function of x is equals to, this is the square root of x to the exponent 2016, x to the exponent 2015 plus x to the exponent 2012. So normally when people see a huge exponent, that's where they get scared. There's nothing here. It's just laws of exponents. Ne? If you remember, okay, we are going to do laws of exponents. If you remember laws of exponents, multiplying powers of the same basis, you add the exponent. A to the exponent n by a to the exponent m is equals to a to the exponent n plus m, right? Dividing powers of the same basis, you subtract the exponents. You know these things all the way from grade 8. We just forget. Dividing powers of the same basis, we subtract. So a to the exponent n divided by a to the exponent m is a to the exponent n minus m, right? Nothing hectic. So that's basically what's going to happen here. Laws of exponents. So with this one, we want to reduce everything to the lowest exponent. The lowest exponent is 2012. We're going to reduce everything to the lowest exponent, which is 2012. So how can we reduce 2016 to 2012 using laws of exponents? Multiplying powers of the same basis, we add the exponent. So we reverse the law. We say it was x to the exponent 2012, which is the highest exponent. It was multiplied by x to the exponent x to the exponent 4, because 2012 plus 4 it will refer 2016. So we basically reversing the law. We are saying x to the exponent 2016 is equals to x to the exponent 2012 multiplied by x to the exponent 4. Multiplying powers of the same basis, we add the exponent 2012 plus 4. Therefore, this is x to the exponent 2016. So basically now what's happening, we are reversing the law. We are going backwards, right? So we are reducing everything to the exponent 2012. So x to the exponent 2012. What do we need? What do we need to add more 2012 to get to 2015? You just need a 3, right? Just need a 3. So we're good. So far, so good. We have reduced everything to the lowest exponent, which is 2012. Okay, so now let's see. Kamotla, we have two terms. We have two terms. This is one term. This is another term. We can take out a common factor. Okay, so go dim, we have x to the exponent 2012 multiplied by x to the exponent 4. So the question, they said we must solve for this without the use of a calculator, right? We must solve for f of x if x is equals to 2, but they said without the use of a calculator. So we are simplifying, and then hopefully we can solve without using a calculator. We take x to the exponent 2012 as a common factor. In this term will be left x to the exponent 3, and then here will be left 1, because we took everything, right? We took everything. And then okay, we have the square root here. Oh, coding, we have one term. This is one term. So now we can cancel the like terms. This and this, they cancel out, right? Okay. In this case, we have x to the exponent 4 all over x to the exponent 3 plus 1, the square root of that, right? So now I think we can do this without using a calculator, because 2 to the exponent 4, we are familiar with that, rather than 2 to the exponent 2016 without a calculator. Yeah. So okay, now let's dial 2 to the exponent 4 over 2 to the exponent 3 plus 1. Remember the question was solve for x without the use of a calculator if solve for f of x without the use of a calculator if x is equals to 2. So we did all this so that we can put it in a familiar territory. if we substitute ka x, we can do it without a calculator, right? Our brain can reduce it to our brain capacity basically. So 2 to the exponent 4, that's 16 all over. 2 to the exponent 3, that's 8, plus 1, the square root of. So basically we have the square root of 16 over 9. The square root of 16 over 9. The square root of 16. Okay, we are using this law. Sorry. So the square root of a over b is the same as the square root of a all over the square root of b, right? So now we are going to apply this rule here. So the square root of 16 is 4, the square root of 9 is 3, right? So that is our 28 marks. So guys, yeah, please do subscribe. I'll be doing more of these videos. Give me the fire, and then also please do comment there. There's a comment section. Please do comment. Otherwise, tell us what you would like us to focus on. Maybe if there's a specific topic you'd like us to work on, please mention it on the comment section down below there. Thank you. Meet you on the next one.